Good afternoon. Thank you for watching this video. Most of you watching this video must be familiar with the phrase parametric equations. Now keep in mind, many of you already know about this. You just don't know about it because it was never formally utilized in the way that it should have been. Intuitively, you are aware of parametric equations. Here we are just formalizing it, and I'm telling you this is not a difficult concept. When you're talking about a parametric equation, it utilizes a parameter. A parameter is a third variable which is brought into your set of equations because you're going to utilize it. A parameter can be any variable like t, it can be theta, but don't use x and y because they represent your traditional variables. You have the basic rectangular equation. These are your equations which have x and y. These are like x is equal to y plus 1 or y is equal to sine x, y is equal to natural log x. Any equation where you just have y and the x, those are your rectangular equations. When you bring in that third parameter like t or theta variable, now you no longer have a rectangular equation but you have a parametric equation. Keep that in mind. A parameter is a third variable brought into your basic equation form to help you analyze. When you're talking about parametric equations, you incorporate your third variable, the parameter. Then you use and analyze your parametric equation, which I'm symbolizing as PE. Then you eliminate that parameter and go back to your rectangular equation form. At your level in the 12th grade, this 1 and 3 are very easy, and in your skill level, the analysis and the use of parametric equations is calculus and not in the 12th grade level. You would be responsible for only 1 and 3, not the 2 part. In this video, let's then stress and emphasize only on the steps 1 and 3. We will bring a parameter, we will incorporate a parameter into a equation form, and then we will eliminate that parameter, and in between we'll show you what the procedure is. In this video, I'm going to use only a single example, and the parameter will be the theta variable. I've already told you earlier that you are all familiar with parametric equations. You've seen it already, just it was never formalized, and this is why. And this is a very important example, a very common example that you have all seen. You just never thought about it in terms of parametric equations. Think about a x and y system. I'm looking here only at the origin. You have a certain right triangle that you develop a certain point over here. You have a certain angle here, you have a certain x and y and a certain radius. Radius here can be any number, 1, 2, 3, 4, 5, whatever, but we're calling it that. With regards to the x dimension, you have cosine theta is equal to x over r. You have sine theta is equal to y over r. If you solve for x, x is equal to r cosine theta. And remember, you've seen this in the form of the unit circle. Because this point here represents a point on your unit circle, that point P always has an x and a y value. That x and the y value are now r cosine theta and r sine theta. And look what we have developed here. We've developed parametric equations. We incorporated a parameter by means of this trigonometry relationship pertaining to a right triangle, everything with regards to a unit circle, and that right here is a parametric equation. X is equal to r cosine theta. A third variable, a parameter has been brought in, y is equal to r sine theta. The use of this, I said, is perhaps not in our 12th grade level, but you know basically the use of this parametric equation or these two parametric equations. This is a parametric equation number 1, this is a parametric equation number 2. There are two. The use of these is to identify a point on your unit circle. But there's more you can do about that, but we're not talking about it. Here we've incorporated the parameter, the theta variable, and we've developed two parametric equations. If you were to now go to step 3, which is eliminate the parameter, how would you go about doing it? I'll show you. The elimination of a parameter depends on the type of parametric equation you have. Here I have a parametric equation, set of parametric equations which relates to a circle, and I'm looking at sines and cosine. The elimination of the parameter usually depends on you recognizing some form of an identity. Think about this identity you all know. Sine square x or sine square theta plus cosine square x or cosine square theta is always equal to 1. It's a very fundamental trigonometric identity. Utilizing that identity, you can eliminate the parameter here, the theta, and go back to a rectangular form. Rectangular form only having x's and y's or any other constants, but the variables will be x's and y's. How would you eliminate that? Well, we know x is here equal to r cosine theta. We know y is equal to r sine theta. If you were to look at these r's, the radius is a constant because the radius of a circle is constant. It doesn't change for that circle, but it could change for a different set of circles. Here radius could be 1, it could be 2, 3, 4, but for this depiction here, the radius, the letter r here is a constant, it's not a variable. You take the r, the constant on the other side, you have x over r is equal to cosine theta. You have here y over r is equal to sine theta. Somehow you need to bring this identity here into this, and you can. You can do so by squaring everything, because when you square everything, you can bring in that identity. Look what happens when you square everything here. You have x squared over r squared is equal to cosine squared theta. When you square here, you have y squared over r squared is equal to sine squared theta. I know by means of some certain famous identity, sine squared theta plus cosine squared theta equals 1. If I could somehow bring that addition property equaling to 1, I can do the same thing with here. If I know cosine squared plus sine squared theta equals 1, then I know what they substitute or what they represent should also equal to 1. I know in all instances cosine squared represents x squared over r squared. It doesn't matter if you're doing sine square x plus cosine square x or cosine square x plus sine square x. Order does not matter when you're adding. In all instances, I know cosine square theta is equal to x squared over r squared, and in all instances, I know sine square theta is equal to y squared over r squared, and in all instances, I know cosine square theta plus sine square theta is always equal to 1. Therefore, their substituents are equal to 1. I can do a common denominator and shoot it across, and I get x squared plus y squared is equal to r squared. I've eliminated the parameter, and I've developed a rectangular equation form which only has the x and the y variables and or a constant, but the parameter is eliminated, and I've arrived at a very useful equation for a unit circle. Based on what this r value could have been, it could have been some number like 2. I could have developed an actual value for a radius. Think about it. If r in both of these instances was a 2, you're bringing a 2 down here, you're squaring it, you're getting a 4 over here, you're getting a 4 over here, you shoot it across, you're getting a 4, x squared plus y squared equals 4. You know you'd have a circle centered about the origin 0, 0. In that case, radius of 2, square root of 4 would be a 2. Based on what you want to adopt as a value of this r, you can actually come up with a numerical value here. Anyhow, what have we shown you here? We've shown you the development of two parametric equations by bringing a third variable, the parameter. The parameter was utilized for a specific purpose. I didn't talk about that purpose, but one of that purposes would be to identify a point on your unit circle, anywhere on your unit circle, by means of this. But there's more you can do with regards to movement of points and all of that, but that's not 12th grade level math. Anyhow, you would have utilized the parameter, you would have done your analysis and all of that, but then you eliminate the parameter and go back to your basic equation form, this. And I've shown you how you eliminated the parameter by recognizing some sort of a trigonometric identity you could utilize to your benefit. That right there is parametric equations. When you see everything here in this form, you now recognize and realize that this perhaps was not too far unfamiliar to you all, because you've seen something like this, but you saw it under the heading of unit circle and or the like, but you never heard of it in terms of parametric equations, when in reality it was. That will be all I'll say in this video. Hopefully you enjoyed it. Thank you for watching. Have a good day.